Hi, I'm Michael Beavers, and today we're going to talk about power and energy. So the scientific definition of power is 1 joule per second equals 1 watt. A little more practical definition might be the rate at which energy is transferred or transformed. So what's the difference between transferred and transformed? We can transfer energy from place to place or transfer electricity from place to place, and it still remains electricity. For instance, we can plug into a 120 volt outlet and charge up a 12 volt battery, and we can monitor the wattage that we've transferred from place to place. Transformed, we change it from electrical energy to something else. Maybe it's mechanical energy, like rotation of a motor, or light energy. We light up a light bulb, or maybe even heat energy. I'm sure you can think of some as well. We measure power in watts, but what we're going to refer to here a little bit is watts per hour. You may or may not know that the utility company charges you by the kilowatt hour, or 1,000 watts per hour. The formula we're going to use is real similar to Ohm's law. It's the pi formula, or PIE as we call it. So it is P, which is power, I, and E. The P stands for power in watts, the I is current in amps, and the E is voltage. Now, we need both current and voltage to talk about power. And I'll give you an example from the Hoover Dam video I did last week. If you remember, Hoover Dam is this huge dam, all kinds of water on one side of it, so there's huge pressure on this dam, and they will open up the gates and let water flow to turn the turbines. What happens if there's no water flow? Well, obviously we don't create any rotation on the turbines, so we don't transfer from one form to the other. What would happen if we also didn't have any water pressure? Well, you know how that works too. If you've ever taken a shower someplace that has a low water pressure, no water really comes out, and it can only turn the turbines very slowly, if at all. So it takes both of those things, voltage and current, or electrical pressure and electrical flow, to create much power in any kind of device. Let's do a couple of examples. So imagine, if you would, that we had 120 volts and 9 amps, and we want to know how many watts that was. So if you remember from our formula, the P would go on the top. We don't know what that is, but we know we have 9 amps, and we know we have 120 volts. So let's do this real quick. So 9 times 120 is going to equal 1,080 watts. So our P is going to be 1,080 watts. Now if we change it to kilowatts, we have to move the decimal place over 3 places, 1, 2, 3, and that would be 1.08 kilowatts. Let's try another one. Let's try, if we have a 1,500 watt curling iron and we've got it plugged into a 120 volt outlet, how many amps does it use? Well, now we know the power, so we'll put that on top, so it's 1,500 watt. We don't know the current, but we do know the voltage, and it's 120. So we're going to take 1,500 divided by 120, and we'll come up with our current. So 1,500 divided by 120 is going to give us 12.5 amps. Now where this might be or become important, if you were going to put in a breaker, you would know that for one curling iron you would need at least a 15 amp breaker, or you're going to trip your circuit. So I is going to equal 12.5 amps. All right, let's give another example. Let's say we have 10 12-watt light bulbs. Oops. And they're each going to be on for 1 hour. So what we want to figure out is how many watts per hour we have. Well, we take the 10 times 12, and so we're going to get 120 watt hours. How many kilowatts hours is this? Well, we have to move the decimal place over 3 places, so there's 1, 2, 3, and that would be 0.12 kilowatt hours. Well, what's going to happen in kilowatt hours if we only run those for half an hour? Well, we already know that 10 times 20, 10 light bulbs times, 10 times 12, or 10 light bulbs times 12 watts is 120. So we're going to take our 120 times 0.5, which is our half an hour, and we end up with 60 watt hours. And how many kilowatts is that? Well, move the decimal place over. 1, 2, 3. So we're going to put a 0 there. And we end up with 0.06 kilowatt hours. What if we ran it for 8 hours a day? So we've got our 10 light bulbs at 12 watts running 8 hours. So we've got 10 times 12 times 8, 960 watt hours. And in kilowatts, that would be, move the decimal place over, 1, 2, 3, 0.96 kilowatt hours. All right, so that gives you an example of how we use the pi formula. If you know the power and one of the other variables, you can solve for the third. So just like Ohm's law, the one variable you don't know, you can easily find if you know the other two. So we talked about a scientific definition of power, and that's 1 joule per second equals 1 watt. We talked about a practical definition, which is the rate at which energy is transferred or transformed. And we said we could transfer electrical energy into all kinds of things: heat, light, motion. And we looked at our formula and a few examples. If you have any questions, please get back with me. Have a great day.